All right, DI 36-2. In this DI here, it's a little difficult because we're going to be using identities to help us. But once we kind of realize what the identity is that we're using, the rest of it is all algebra. So I'm going to be spending a lot of time kind of showing you what the identities would be when we use this, and a little bit less on the algebra part. So on number 1, sine of 2x equals cosine of x. So we want to get rid of all of our sine of 2x's, or anything that has like a 2x in there, because right now there's no way I can combine these or simplify these. And so this sine of 2x is the same as 2 sine x cosine x, and that equals cosine x. Then I could subtract cosine of x on both sides. So I get 2 sine x cosine x minus cosine x, and that equals 0. So now that my equation is equal to 0, I can hopefully try and use the zero product property, which means I want things to be multiplying to each other, because if they are, then I can set each factor equal to 0. So I need to factor this, and if you notice, there's a cosine in common. And so now I can set each one of these equal to 0. So I can say cosine of x equals 0, and I have 2 sine of x minus 1 equals 0. For this one, I can take the cosine inverse to both sides. So I have x equals cosine inverse of 0. And then from there, you do what we did yesterday. For here, I have to add 1, divide by 2. So I have sine x equals 1/2. Then take the sine inverse to both sides. So x equals sine inverse of 1/2. And then do what we did yesterday. Number 2, cosine of 2x equals 2 minus 5 cosine x. So for this one, once again, we're going to use, this is a double angle identity, but it looks like I have other cosines. There are multiple options for that double angle identity, and in this instance, we want to make them all cosines, because then I'm going to be able to factor this. So this is 2 cosine squared x minus 1. Now I can bring everything to one side. Combine like terms. Now I know this is kind of hard to visualize, but the cosine squareds, what if I replace that with, let's say, u? That's much easier for me to visualize, to be able to go through and factor this. And so now, figuring out how to factor this, a times c, get -6, factors of -6, that add to +5. So that's going to be a +6 and a -1. So this would be 2u squared, I'll do minus u first, plus 6u minus 3 equals 0. Factor out a u, factor out a 3, because it's factored by grouping. And so now I'm going to replace the u's back with cosines. Well, alright, I'll finish the last step. 2u minus 1, u plus 3. And this all equals 0. And so now I can replace the u's back with cosines. So this is going to be 2 cosine x minus 1 and cosine x plus 3 equals 0. Now with that statement there, set each one of these equal to 0. So 2 cosine x minus 1 equals 0, and cosine x plus 3 equals 0. Now you're going to find out this one here, you can't have the inverse of -3. It's outside of what the domain is. The domain should be -1 to +1, and that's -3. So this does not exist. Not applicable, does not exist, undefined. That's what this factor is. But this one you can find. If I add 1, divide by 2, cosine x equals 1/2. Now I can do the cosine inverse to both sides. So x equals cosine inverse of 1/2. And then from there, go through and do what we did yesterday. For number 3, tangent x equals secant x. I want to change everything to sines and cosines. So I get sine x over cosine x equals 1 over cosine x. Now I want to multiply both sides by cosine. And so now, when we do that, cosine cancels out here, cosine cancels out here. So now I have the sine of x equals 1. And then I can solve for sine there. Now the only thing that we have to be careful though is because we do have a cosine in the denominator, we have to check for extraneous solutions. So check undefined values. So when you get your final answer, you got to plug it back in to see to make sure that you're not plugging it into an undefined value. So like for example, what if sine was, we got pi halves? Well, if I plug pi halves back into this problem, is it going to give me undefined? Because you may be surprised. All right. It says 3 cosine of 2x equals sine of x plus 2. This one is going to be similar to problem number 2. With the cosine of 2x, we're going to have to use the double angle identity that turns everything into sine. And the reason being is because this is a sine, and I want everything to be sine so that I could then factor and do all those things that I need to do. Number 5, sine of 3x cosine of x equals cosine of 3x sine of x. So if I subtract that, that's going to give me the sine of 3x cosine of x minus cosine of 3x sine of x, and that equals 0. That is a sum and difference identity. That's the sine. So it's the sine of u, and that's because that's a minus v. So this is my u, and this is my v. And so this is going to be the sine of 3x minus x, which is the sine of 2x. And so now I can just solve for it. Take the inverse to both sides, dot, dot, dot. Now, numbers 6 and 7 are very, very similar. Those are sum and difference identities. For number 6, that looks like the sum and difference identity for cosine, and same with number 7. Now remember, when you use the sum and difference identity for cosine, the sign changes. So because that's a plus, that means when you write it like this, it's going to be a minus. Because that's a minus, when you write it like this, that's going to be plus. And then number 8, it says the absolute value of 3x minus 5 is less than or equal to 4. So less than, so that's an and statement. So that means I want to see where do they intersect. So solving for these, I get 2 of them. 3x minus 5. Here is the positive one. And here is the negative one. Right, that's if I, if that was negative and I divide both sides by the negative. Add 5, 3x is less than or equal to 9. This one, add 5, divide by 3, I get x is greater than or equal to negative 1/3. So on our number line, I have negative 1/3. I have 3. X is less than that. X is greater than that. So where they intersect is here. So my answer is negative 1/3 to 3.